scheduling algorithm. This is the last video continuation because in the last video I have already taken the first two CPU scheduling algorithms. That is first come first serve and shortest job first. So this is the third CPU scheduling algorithm. The name is priority scheduling. So in this CPU scheduling algorithm, each processor in the processor queue has a priority value. That priority value is assigned by operating system. Operating system assigns the priority value to each and every processor based on its memory requirement, time requirement and other resources requirements. So based on the priority, the CPU schedules the process to execute. Okay. So this is also the non-preemptive algorithm because non-preemptive algorithm means once the process is occupied the CPU, it's continuing its process until it's finished its execution completely. So that is the non-preemptive algorithm. So this is one of the non-preemptive algorithm. It is a commonly used algorithm. So now we see the example to how the priority scheduling algorithm is processed. So this is the examples. In this table we are having the processes, priority value of each and every processes and then bursting time. So the burst time is nothing but the process how many times occupied the CPU. The time, milliseconds of time is the burst time. So in this table we are having the four processor P0, P1, P2, P3 mainly. Then the P0 process has the priority value 1 and its burst time is 5. And the process P1 has the priority value 2 and its burst time is 3. And then the process P2 has the priority value 1 and its burst time is 8. And P3 process has the priority value 3 and its burst time is 6. So based on this priority value, we have to first select, the CPU first select which one is the highest priority value. So you see in this example 3 is the highest priority value. So that process is P3. So in the con chart, by using the con chart we have to know how the waiting time of each and every process is estimated. Based on the waiting time of the processors, we can choose which CPU scheduling algorithm is best one. So for finding the waiting time of each and every processors and average waiting time of those processors, we have to use con chart. So in this con chart, how the CPU is allocated, first which one is the highest priority value, the process P3 has the highest priority value 3. So that P3 is assigned first. So what is the first time of the P3? 6. So 0th millisecond it enter into the CPU and it exit from the CPU at the 6th millisecond. So because it first time is 6 milliseconds, so 6 milliseconds is occupied the CPU. After the 6 milliseconds, the P3 completed its work, so it quit from the CPU. The next, which one has the next priority value highest one? 2. So the second priority value, so that is P1. So P1 process has the second value, P1 process has 2 priority values. So this is the next one. So that is entered into the CPU next. So P1 entered the CPU at 60 milliseconds. What is the first time for the P1? 3. So it occupies 3 milliseconds to the CPU. So until the 9 milliseconds P1 occupied the CPU. So the next, which one is the highest priority? P0 and P2. These two has the same priority value. In this situation, we have to use CPU use the first come first serve based. Okay. So which one is come first? That is serve first. So P0 is the first come. So the first time of P0 is 5. So 5 milliseconds is occupied the CPU. So 9 to 14 seconds is occupied P0 occupied the CPU. So on the 14th seconds only the process P2 entered the CPU and its first time is 8. So 14 plus 8, 22. So in the 22nd millisecond P2 quit from the CPU. So according to this con chart, we can know the waiting time of each and every processor. So we see P0. So P0 is the waiting time of the P0 is 8 because its enter time is 9 milliseconds. 9 milliseconds means 0 to 8 milliseconds it waits in the processor queue. So the waiting time of the P0 is 8. The next one is the P1 process. The waiting time of the P1 process is 5 because it entered into the CPU is 6 milliseconds. So up to the 6th milliseconds it waits in the process queue. So 5 milliseconds is the waiting time of process P1. The next one is the P2. So P2 enter the CPU 14th milliseconds. So obtain the 13 milliseconds is waits in the process queue. So the waiting time of the P2 is 13. The next P3. So P3 is not waiting any more time in the processor queue. It first allocates. So the 0th millisecond is the waiting time of the P3. So we have to add these four values and divided by 4. We have to find the average of those. The average of those is 6.5 milliseconds. So similarly, this is the principle of finding the waiting time for the processors used in the priority CPU scheduling.